Hey, good morning, guys. Welcome to our 9th Fusion Friday. My name is Brian Monkapunsuk.
My name is Alex Alvarez.
And we're application engineers here at Kativ Technologies on the Fusion team. And yeah, good morning. This has been a busy week. We had the World Series. We had our meetup on Wednesday at the Haas Factory outlet in Torrance. Shout out to those guys for helping it all become helping it to become a success. Thanks for you guys who came out to that event. We made a Fusion keychain, which Alex will be showing in this demonstration.
It was a pretty good turnout. We had a good crowd, good conversations going on as well. So yeah, really glad
we're definitely looking to hosting another one of those in the near future as well. But for today, we will be talking, or Alex will be showing us a little bit of 3D machining, and it's going to be a little similar to the topics that we discussed at the meetup, in case some of you guys couldn't make it. Absolutely. And for those of you who are new to our Fusion Fridays, it's a series of webinars that we host on the first Friday of every month. We cover topics on Fusion 360 and the different workspaces it has. But now, instead of on the first Friday of every month, we're going to be doing this every other week.
Bi-weekly, that's correct.
Yep. So we're going to pick up the speed here I can see for Fusion. So, but without further ado, I'm going to pass it on now to Alex, and he's going to show us some fun Fusion demoing here.
Perfect. Thank you for that, Ryan. All right, so before we do get started, I want to give a quick overview on Fusion 360, right? So it's a cloud-based CAD/CAM collaboration tool that really, I feel, takes simplicity to a whole new level, right? So if you take a look up here, we see that we have the 3 pillars that Fusion 360 was built on. All right, so Autodesk wanted a tool that took you from the design stage of your product all the way to the manufacturing stage without having to leave that tool. Right, so we take a look at that workflow before. It could be anywhere from 3, 4, maybe even 5 different tools, depending on the company that you were working with. But with Fusion 360, we bring that down to one tool, giving your team a much more integrated experience. Right, we also have connected. So Fusion 360 is connected to the cloud. What that means for you is that you can now leverage today's modern technology and really take advantage of the computing power that comes with the cloud, right? But connected also means connecting people. Right. Before, we used to send emails, maybe set up Dropbox and send the multiple models or files that we had. But that you ran a risk of possibly losing a file, maybe losing the something important along the lines, right, of that disconnected workflow. So why not have your data accessible to you in one seamless, easy to access environment? Right, and then finally we have accessible. So Fusion 360 is accessible on both Windows and Mac platform. You don't need to run boot camp on your Mac anymore to have access to Fusion 360, right? So accessible also means accessing your data anywhere. Again, going back to being connected to the cloud, you really have the ability to access your data wherever you go.
You can even access it on a tablet or smartphones. There's an app for Fusion 360 as well.
Right. Okay, so here we have the Fusion keychain, right? So we decided to make a Fusion keychain out of the Fusion logo for the demo. Now, I get it, not that much complexity to the Fusion logo, really not that much functionality to the keychain either, right? But if you think about it, that workflow is going to be pretty similar to what today's machine shops or maybe some of the businesses are going through, in the sense that you get a model, you either import it from a customer, maybe you design it yourselves, and then you have to think about a way to manufacture that part, right? Are you going to be using subtractive manufacturing, additive manufacturing? In our case, we decided to go with subtractive manufacturing, right? We're going to be machining this part. So with that comes, how are you going to be holding it, right? So the first couple of operations, yeah, they're going to be pretty simple. You're working with a predefined stock, a rectangular stock in our case. So it was pretty easy to hold. But after you start removing material, you start getting some more intricate shapes. And you as a designer, engineer, or machinist have to come up with some pretty unique ways on how to hold your part, whether that be fixturing, or in our case, we decided to go with a set of soft jaws to hold the part, right? So for this demo, we are going to walk you through that entire workflow and hopefully give you a pretty good taste of what Fusion 360 can do and some of its capabilities.
Right, and if you guys have any questions during this presentation or Fusion 360 in general, feel free to ask it here in the comments section.
Absolutely.
And then we'll gladly address them at the end.
Okay, so this part is going to require both 2D and 3D machining, right? So I just want to go over a quick overview on these 2 different toolpaths. So starting off with 2D toolpaths, they are strictly driven off of 2D geometry, right? So all the toolpath in kernel sees then is a 2D feature that you have selected for that given operation. So if you take a look here at the pocket, we see that we have that pocket selected. In return, then Fusion 360 is just going to focus on that pocket and create toolpaths for that pocket specifically. Right? Pretty straightforward, not that much to it, right? So process-based CAM like HSM, you'll hear me interchange HSM and Fusion 360. Just know that HSM is built into Fusion 360, so that's what I'm referring to when I say that. Right, so process-based CAM like HSM defines these 2D features with what we call chains. Right, so looking at the pocket again, we see that there's a little blue outline around the pocket. That's what we like to call a chain, right? So this process is then streamlined by adding artificial intelligence to the selection process. So things like auto detecting open and closed loops, islands, bosses, even intelligently selecting the chain direction when selecting your chain, right? So again, pretty straightforward when it comes to 2D toolpaths. There's not that much to it. They're not really that complicated. When we do start getting into a more complicated topic is when we start talking about 3D toolpaths, right? So the best way I can really explain 3D toolpaths is with the use of an analogy, right? So I have a good friend of mine who's known as the Bear Man. Now, he's referred to as a Bear Man because he does bear carvings out of wood. Now, that's not him on the right, by the way. That's just, I guess, random picture I found online. But yeah, he does bear carvings out of wood. And if you look at the bear carving, there's so many ways that you can approach the bear, right? So many different angles that you can come at it. So I decided to ask him one day, how do you know exactly where to start? And his answer was pretty simple, right? He simply said, I cut away everything from the tree that isn't a bear, right? He carves away everything from the tree that isn't a bear. So if you think about it, that same concept applies to 3D toolpaths in the sense that Fusion 360 looks at your model, it looks at the stock that you have predefined, right? And then it starts removing material away from the stock until it gets to the model or as close as it possibly can to the model, right? So if you take a look at the picture in the middle, notice that we have some sort of 3D toolpath on the free-flowing surface, right? Notice that it's also contained because, like I mentioned, it looks at the entire model, but for this case, we just contained it to those free-flowing surfaces. Now, you're not just limited to adding 3D toolpaths to free-flowing surfaces. If you take a look at the picture on the left, we also apply 3D toolpaths to a prismatic part, right? So you're not limited to just working on certain models with certain toolpaths, right? You have the liberty to really experiment with these toolpaths and see what works best for you. All right, so that was my little spiel on toolpaths. So let's go ahead and jump into Fusion then and get the ball rolling. Right, so notice that we have Fusion here. We're in the modeling workspace, right? So what's neat about this is that the same tool that we're using to model this part, right, to create all the sketches, all the features, is the same tool that we're going to be using to create toolpaths. So what's neat about this is that any change I make to that model or any update is going to also update the toolpaths that I have for it, right? So again, that's going back to the integrated CAD CAM and the efficiency that comes along with that. Now, during the event, we were lucky enough to have a set of soft jaws donated to us by Chick Workholding. So if you take a look here, this is a data panel, right? Data panel essentially is where you have all your projects stored. The way I typically like to work about this is each different customer, I create a project, and then once I do have that project created, if I do want to invite some people over, I just simply go over here to the People's tab and invite them over, right? And they have complete access to those files, and really they can make any changes they want to the model as well.
And this eliminates the need for Dropbox and emailing each other. So instead of paying your engineers to manage data, you're actually paying them to design and create toolpaths.
Exactly. Right. So now scrolling down here on the data panel, notice that we have this CAM samples option here on the bottom, right? If we go ahead and click on that, notice that you have dozens of parts here. What's neat about this is that if you're ever wondering on how to do some sort of toolpath, whether it be 2D toolpaths or maybe some turning or 3D toolpaths, right? You can always open these parts up. And what's neat about this is that the program or the CAM setup is already going to be attached to this file, right? So if you're ever wondering on how to do a certain operation, or maybe some of the options that these people are selecting when it comes to this, you can simply open it up and dissect the part, really, right? And really go into the details of the toolpaths. So the reason why I'm in here is because we have this work holding folder. So click on the work holding. Notice that we have this check work holding folder, the subfolder as well, right?
And there's a bunch of other different devices you can pull from.
Yeah.
And if you can't find it here, you can also look on the your manufacturer's website for your device, and you can download the file from there into Fusion.
Absolutely right. And we have this check quick clock 1030 that we had available to us at the Haas factory, right? So notice that when we open it up, we have pretty much all the constraints or the joints attached to it, except for the jaws, right? So as we would expect, we have the free-flowing jaws here moving. So what we can do there then is go back to our project. Let's say we're going to go into this project, right? And then save it as, right? So what that's going to do then is bring this part into our project. Now what we can do here then is create some templates from this file, right? So you don't have to go back into the cam samples and download that part every time you want to create soft jaws, right? So again, extremely easy to go back and forth and really create some sort of template working with this device, right? So I already had one that was pretty much predefined. So notice here that I have modeled my stock. Now I modeled it a specific way, right? I modeled the stock in this position because whenever we start, we actually made 40 of these parts, right? We don't want to go ahead and do a probing operation for each keychain, and I didn't really want to maybe create some sort of locating feature here. So what we did here then is create the stock flush with the jaw. So every time the machinist goes and creates a new part or machines a new part, he just simply has to line it up flush with the vise, and we have, you know, we already know we're going to be located correctly. Right? So again, removing the need to really spend much more time locating your part in the vise.
Right. And if you guys have any other vices that you might want to see in future Fusion 360 Cam videos, feel free to leave that in the comments as well.
Yeah, or you can even go to the manufacturer website, right, and then upload. Usually they have the 3D model there. They may not have a Fusion file. A lot of them have a step file, maybe a SolidWorks file. What's neat about Fusion is that you can go ahead and download that, and notice all the different file types that you can import into Fusion, right? So you're not just limited to working with Fusion 360 files. You have the ability to download really multiple files onto here.
Right.
All right, so moving forward then, now we want to go ahead and create the soft jaw for the top fixture, right? We're going to machine the top section here, and then we're going to do a roughing operation here on the outside to create the profile. So when we do create that profile, we have to come up with a way of how to hold it in this vise, right? So what we can do then is create a copy of the keychain, make sure that you have the copy selected, and then just simply drag it into place, right? So here, you pretty much just want to place it somewhere where you would want to see your part. I'm going to be locating it like this. Okay. Now, the neat thing about this is that, again, going back to the integrated CAD CAM, right? We're going to create our soft jaws and our part all within the same environment, right? So going back into the CAM workspace, once we do go into the CAM workspace, what I can do then is have one single G54 or one single work coordinate. And now I don't have to worry about exactly where this part is going to be located, right? I don't have to be too worried about that when I'm machining it. So that looks pretty good there. Let me go ahead and just sit it flush with the face. So what I can do there then is just select that, select this face, align the components. So what I did there then is I essentially made this flush, but I still have the ability to move it, right? So again, doing one more move operation, I want to go below 100 thousandths, 0.1.
And if you guys want to see your part and see how it fits into a vise like Alex is doing with this part right here, we also offer Ecative demos, like 10 to 15-minute demos with webinars with either Alex or I, and we'd love to show us setting up your part in our vices or in your vices as well.
Yeah, absolutely. You can just go ahead and let us know there. So while doing this, I noticed that I forgot a pretty important step, right? If we take a look here, we see that we still haven't fully constrained this jaw. So let's go ahead and do that. Again, I'm going to hit J for joint. The way joints work, I'm not going to get too deep into joints, but the way joints work is you always want to select the part that's going to be moving in respect to your other part, right? So we're going to select these two. There's already a joint there.
He's able to use the power of the model workspace, even though this is also a CAM tool.
So I did space this 3/8 of an inch, right? So that was just a preference of mine. So I'm going to go ahead and space it 3/8 of an inch. Now what I can do here is I can add a note during the CAM operation, right? Maybe let the machinist know that when he's going to machine these soft jaws, we want to make sure that we do that 3/8 space when machining.
And you can put like a tool that's 3/8 inch diameter in between.
Right, just have some sort of space in there, right? So notice that we have the part then located pretty close to where we want. Now what we want to do then is do some sort of Boolean operation, right? A lot of people are familiar with Boolean operation. In Fusion, we call it combine, right? So pretty counterintuitive to what we're going to be doing. But let me go ahead and show you guys how exactly we go about that, right? So the operation isn't going to be a join. We're going to be doing a cut operation. Notice that we get a little preview. Repeating that same operation. So now if we hide the keychain, what do we have? We have the outline of the keychain in there, right?
And you didn't have to do any like project sketch or anything like that. It was just use the model itself to subtract that.
So notice here too, the neat thing about this is that Fusion 360 isn't just a parametric modeler, right? You can also do direct modeling inside of Fusion 360. So here's what that means for you then. Come over here, hit delete. Right. Notice how Fusion 360 is smart enough to pick up that face or that body, delete it, and do some self-healing and correct itself.
Right. And what Alice just showed us was really powerful and exclusive to Fusion 360, which is the direct modeling features that it has. Fusion has parametric modeling, really good at surface modeling, and direct modeling. And what's neat about direct modeling is like what you just saw. He deleted a face, and then there was another face hanging in the air, and that was deleted as well because Fusion noticed that that wasn't a necessary part to the model anymore. And then it repairs itself too. It's smart enough to repair itself after he's like he's showing you guys right now. He's deleting the faces to the lettering right there.
Yeah. So maybe in another software, you would have maybe had to go back in there, maybe patch it up, maybe tried suppressing that right in the timeline or your design history.
And also what's neat about this is that if you get files from other software where normally other software would read it as a dumb body with no sketches and you can't do anything to it. But here in Fusion, you can actually do the direct modeling and edit, and you can change radiuses. You can pull faces and all sorts of things.
Absolutely. All right. So notice here that we're almost done creating the soft jaws, right? What has that been? 3-4 minutes, 5 minutes, right? And we're almost done creating the soft jaws in here. So we still have some work to do though. Let's go ahead and create some reliefs for these sharp edges, right? So what we like to call dog bones. Now you would want to do that because when you're going to be clamping your part in, sometimes these edges aren't perfect, right? So what that's going to happen then is it's going to pinch your part. It might bring it up, right? So if you have maybe an 1/8 inch end mill, right? That's a pretty thin end mill going around your part, and you have the part lifted a little bit, you run the possibility of possibly breaking your end mill if you have some sort of offset surface that you didn't account for, right? So we want to make sure that we provide some relief around these edges here. So what we can do then is just simply create a sketch on that face, create a circle. Now I'm not going to be too precise with the relief entities here, so
yeah, but these are the kind of things that you wouldn't normally expect if you're just a CAD modeler or a CAM creator. If you're a machinist, this is something that's second nature to you.
Right. Yeah. You might have not expected it, right? You maybe would have just sent it out like this. Your machinist would have came back to you after creating the toolpaths and told you, hey, create some relief relief points there. So let me go ahead and add.
So if you guys ever have any questions or concerns regarding creating toolpaths or just machining in creating toolpaths in Fusion 360, feel free to contact us. We'll have some of that contact information here at the end of the presentation.
Notice I went 0.295. That's because we have an M drill bit that was available to us, right? So we just want to go ahead and create those circles there. All right, so now finally doing a quick cut operation. Okay, I would want to remove this as well too, right? This isn't really too, it's not necessary for the soft jaws in the sense that nothing's going to be happening here. All the holding force or the counting force is going to happen around these surfaces, right? So let me go ahead and create another quick sketch here. Project that. And just make these collinear, E for extrude.
Yeah, and this is a part, once again, that we did at the Fusion 360 meetup, and these soft jaws were machined, and it produced just a bunch of parts. Guys at Haas helped us to machine some of these parts out for us.
Yeah, we were able to do 40 parts, I believe we did.
Yeah.
So decent amount of parts with these soft jaws as well. So now just providing some fillets here. We really don't need these sharp edges, so let's go ahead and remove those. Okay, one. And there you have it, guys. We pretty much just created. We actually did create the soft jaws that we used for the demo there, right? If you want to see how the part looks inside of there, you can do that. Okay, so now all we have to do then really is go into the CAM workspace, and where are we going to start creating our toolpaths, right? So very easy, very intuitive workflow to follow if you're doing manufacturing in-house and design as well, right? You sometimes maybe have multiple iterations of a part, or maybe you're going to reposition this model, right? You would want to go ahead and have the ability to do that, and then not recreate your CAM setup, right? So here, starting off then creating a setup. Notice that we're in the CAM workspace now, right? If you are new to the CAM workspace, it's a very intuitive workflow to follow in the sense that you're going to be working from left to right. Notice that we're going to have to be starting off with the setup. Then we're going to create some toolpaths, add or simulate the toolpaths that we have laid out, and then finally post your program, right? So this workflow may seem pretty familiar to users that maybe use Inventor HSM or HSM Works for the SolidWorks add-in. And that's because, again, HSM is built into this, right? So if you are coming from HSM, this workflow is going to be extremely similar to that.
Yeah, it's a very user-friendly user interface. So it's, especially if you guys are new to Fusion, it's really easy to pick up.
Mm-hmm. So notice too how we hover over an option here or command. We get a little dialog box indicating what that command is going to be doing, and as well as a picture of what that option is going to be doing. So notice that for the setup, we're going to be creating or specifying the stock and the work coordinate system for our part. All right, so creating the setup, again, starting off with the soft jaws. Now I made a stock for these soft jaws, being that I wanted to exactly replicate the 3/8 inch gap that we were going to have in here. So I wanted some appropriate toolpaths for that, right? So let me go ahead and hide some of these bodies here. So now selecting the stock, notice that we have multiple options here. The last option is a from solid.
Okay. Right, and that yellow box is representing the stock or the material that he's going to chip away from.
Mm-hmm. So let's go ahead and click OK, right? So notice here I made a mistake, right? So there's something wrong with this, right? So if you take a look at the work coordinate system, this is saying that we're essentially going to be machining this part like this, right? Which is very wrong.
If you guys see that Z-axis is pointing to the left there, it should be pointing upwards.
Yeah, so let's go ahead back into the setup, change that, right? Very easy to go back into the work coordinate and into your setup and change the work coordinate system there. So turning on the base, some of these parts again. All right, so let's go ahead and reorient the work coordinate system. Now, I want to go ahead and, like I mentioned, work off of one G54, right, or one work coordinate system. Let's go ahead and work off of this fixed point on the jaw. So then all of our points, then we can just simply do one operation to probe on this corner, and all the toolpaths are going to be referenced off of this corner, right? So very easy to follow, and very easy for your machinist to understand as well. Let's go ahead and click OK. Notice that we pretty much all that we have to do now then is add some toolpaths. So let's go ahead and hide a couple of these bodies. We're going to start off with the roughing operation, right? So again, starting off with the roughing operation, notice that we have these 5 tabs on the top. This workflow or these 5 tabs are going to remain consistent for all the toolpaths that you have selected. So you never have to second guess yourself where a certain option is at. You always have the ability to really follow this workflow and understand where each option is going to be at, right? So very intuitive for the users to follow.
So once you know how to do these 5 tabs on one of the tools, it's going to be very easy for you to follow that same procedure for the other tools as well.
Mm-hmm. So the first tab is going to be a tool tab, right? We have to select which tool we're going to be using. Notice that we get this dialog box for the tools. If you take a look here, we also have the cloud tool, right? What that means is that if I have a tool library under the cloud dropdown, I go to John's shop down the street, log into Fusion 360 with my credentials, I'm going to see that tool library available to me. So that's going back to the presentation or to the PowerPoint, with what Brian said, that data is always accessible to you. You don't have to carry around any USB drives or maybe send an email with your tool library. It's always going to be accessible to you.
Right. And everyone in your team can have access to the same library. So you guys aren't pulling just random tools that you may or may not have at the shop. This will be from the same library. You can make even custom tools that I think Alex might go into. And it's just very, very a powerful feature that no other software yet has because it's connected to the cloud.
Right. So yeah, let me go ahead and create a tool then, just for the sake of it. Notice here that we have, again, a couple tabs. The first tab indicating what tool we're going to be creating. Let's say we're going to use a flat end mill. Specify the material of it. Now the diameter, let's say it's going to be 1/2 inch. Right. We had a pretty good question during the day of the demo, and they were asking if we can have a certain tool for a certain operation, right, with different feeds and speeds. I mean, the same tool, same diameter, same variables or same parameters there, just with different feeds and speeds. And the answer is yes. You can definitely go ahead and create a copy of the tool with the same tool number. And the only thing you would change then is the feeds and speeds for whichever operation you're going to be doing. Right?
So pretty much you're setting up the default for this tool. So then every time you pull it up, you don't have to keep changing the feeds and speeds later down the line.
Right. So notice if you have a custom shaft for your tool, you have the ability to play around with that. You have the ability to select which holder you're going to be using. So I highly recommend you do have the correct holder modeled or picked out. And that's because when you simulate your toolpath, you want to make sure that there aren't any collisions when simulating, right? And again, that's going to be the power of simulation and the ability that you have knowing that the toolpaths are going to be working when you go to your machine. So then the most important tab, in my opinion, is the feeds and speeds tab. So going back to what Brian was saying is that you can go ahead and really set your feeds and speeds here and get a default for all your parameters that you're going to be using for that toolpath. So whenever you do create that different toolpath, you don't have to go back in there and change your feeds and speeds when working there. Right, so then post processor, let's say this is tool number 36. Click OK. Notice that we have tool 36 now there, right? So I was going to start working off with the 1/4 inch flat for this operation. Click OK. Notice we have a 1/4 inch flat, and notice that all the parameters that I had predefined for that tool are already set here in this bottom dialog box, right? So 12,000 RPMs. And 250 inches per minute. So we're really pushing this machine. So now the next tab over then is going to be the geometry tab. Select which pockets you want to machine. I want to go ahead and machine these. Oh, let me go ahead and delete that. These pockets here. Click OK. Right, and we got a preview of what we're going to be.
And notice how this is the 2D adaptive. So these are so Fusion has what we call what was it called, adaptive clearing.
Yeah, so that's really the moneymaker for HSM, right? It's adaptive clearing, and the reason here is, let me go ahead and create a quick pocket operation. Now I can go over here to the top, create a pocket operation, but let me just go ahead and create a derived operation. essentially what that's doing is selecting the same tool, same geometry. It's just going to be a different toolpath.
And the neat thing about this toolpath is that it gives the tool constant engagement to the stock. So it gives you a longer tool life and more efficient machining.
Mm-hmm. Right. So if you take a look at the pocket operation, then notice how we have these sharp points on some of these certain points of the toolpath, right? So whereas adaptive really has these smooth transitions or these smooth arcs. So what that's allowing us to do then is have constant tool load, right? You're not going to have cyclic tool loading where you load the tool, unload the tool, right? Load the tool and then unload it. What that means for you then is that you can machine a lot faster while at the same time having or extending the life of your tool, right? So again, during these sharp points, a lot of people would know that you are going to increase the load of your tool. Not only are you going to increase the load, you're probably going to hear a pretty loud noise or screech, and you're going to unload again as you're coming over here, and then load the tool once more, right? So again, 2D adaptive, that's the reason why we're able to really push these tools sometimes a lot faster, and that's because of this toolpath.
Yeah, you really don't want to hear those loud screeches. It gives me a mini heart attack every time.
Right, so here we have a 2D adaptive. Now what we can do then is come back with the 2D contour. So again, I can go up to the top, select the 2D contour, or I can just go ahead and create a derived operation, 2D milling, contour. Now, the height is always, by default, we're going to have the bottom height be the selected contour. In this case, let's just say I want to be 5/10 of 1,000 above the selected contour, right? I don't want to really touch the floor at all. I want to be 5/10 above. And then for the passes, let me go ahead and remove some extra material. So notice that we have this stock to leave option, right? So what you can do then is have a negative stock to leave. So what that's going to be doing is that it's going to be removing whatever value you have in here of material more. So I want to go ahead and remove 10 thousandths.
This is just so your part can fit.
Right, adding some tolerance to it. Again, this isn't extremely crucial, being that we have this gap here, so we can always close it up if we need to, right? So I'd rather have more of a leeway when it comes to this. Okay, minus 0.01, right? And we have the 2D contour here. So now finally, let's go ahead and add the drills here. So selecting again the same tool, that's going to be the first tab, 0.295 drill. Select the hole. Now I can go ahead and select each hole, or I have this option to select same diameter. So imagine if we had hundreds of holes to drill out, you wouldn't want to go and do that hundreds of times, right?
Yeah.
So select same diameter. We get a little preview also of how deep the drill is going to be going. Notice that the tip's going to the bottom, but I want to drill the tip through the bottom of that hole. All right. Click OK. Now, I really don't want to have the drilling operation after the adaptive and after the contour. So let's have the drill operation be the first operation, right? Simply drag it up, and now we have the essentially the program for the soft jaws. You can go over here, rename them. Oh, come on. There you go. Soft jaws, and there we have the program for the soft jaws, right? So very easy. Now what we want to do then is focus on the part itself. Let me go ahead and simulate this real quick while get everything else ready. Quick simulation. All right, and there we have it.
And this simulation allows you to see especially if you leave the stop on collision check, if your tool or your tool holder will crash into either the vise or the part itself. Mm-hmm. But from what it looked like it did a clean cut.
Yeah, absolutely. All right, so let's go ahead and focus. I noticed that we're running a little short on time here. Let me go ahead and start going through this. So again, creating the setup, right? That's going to be the first option there. Now, the thing with this is that Fusion 360 automatically picks the entire model as a relative size box, right? So it thinks that it wants to machine all of this. Let's go ahead and change that from solid. We want to machine off of this stock. Now we have to let Fusion know what we're going to be machining. So let's go ahead and select hide the stock, select this part, right? So notice that our work coordinate system, again, isn't in the correct orientation. Let's go ahead and fix that. We have a selected point. Okay, and everything looks good. So let's go ahead and click OK. Now, the first operation on this would be a facing operation, right? So if we take a look at the facing operation, the icon next to the facing operation is the same thing as the icon up here. So what that's indicating to us then is that it's by default, it's going to go to a facing operation.
So you're going to have quicker access to everything you put up there at the toolbar. You're allowed to pin different tools up there at that toolbar for that, like quick and easy access.
Right. All right. So then we're going to have a 2-inch face mill. Again, feeds and speeds are already there for me. Click OK, right? And we get the correct toolpath for it. So if we go ahead and simulate it, right? So that looks like it may be a little bit too much material removed that in a single pass. So let's go ahead and change that. Again, really easy to go back into the toolpath and change it or make any edits. That's going to be under the passes tab, multiple depths. Let's leave 70 thousandths. Okay. Click OK. Right. So now we have a better looking toolpath. Right. So again, going back over here, doing a 2D adaptive clearing, we want to rough out the outside of the part. Now, by default, again, Fusion 360 remembers the last tool that you had, and it applies it to the toolpath. Let's go ahead and change that though to a 1/4 inch flat.
As you guys notice, as Alex is working, it's just a lot of the same consistent windows that are popping up. A lot of the same, the feeds and speeds are already like defaulted to what he said previously. So now he just needs to worry about selecting the profiles.
Right. So notice how this toolpath isn't going all the way down. So again, by default, it's going up to that contour. Let me go ahead and change the height. I don't want to go to the selected contour. I want to make a selection of how low the tool can go. that wasn't planned, I promise. All right, click OK, and we get a better looking toolpath, right? So again, finally doing a finishing operation on this. So again, very repetitive, very that same workflow is always going to be consistent. Clicking OK, we get a contour, and then let me just go ahead and add a chamfer and an engrave here. So 2D chamfer, right? We want to chamfer around the part, break off all the sharp edges, and let's see here, tool that we're going to be selecting, 1/4 inch chamfer mill. Chamfer this out. And for the chamfer, you have a chamfer width and chamfer tip offset. I typically like to leave these the same. And let's say we have a 20 thousandths chamfer. Click OK. Perfect. All right. So I am running a little short on time, so let me go ahead and just jump over to the other side. So the other side is going to be a little bit more complicated, right? We are going to have some more of these surfacing toolpaths, right? So with 3D toolpaths, really, like I mentioned, the trick to them, or I guess the more complexity to them, is knowing when to contain them. What I like to do with those is usually start off with the toolpath and do nothing but just select the tool and then click OK, right? And see what the toolpath gives me. Now, with that, you always run the risk of, having a funky looking toolpath. But what I like to do then is go into the options and then start selecting, or start checking off a few of the options and then trying to contain the toolpath that way. Because if you start selecting all these multiple options right away, you're not going to know what's causing the toolpath to error out possibly, or which option you selected that's just throwing the toolpath off in general. All right, so here I believe it was 1 3/4 by 3 1/4. The depth of it. So the depth was 5/8. Yeah, so the thickness of the part was 5/8. We took off 100 thousandths. So let's go ahead and apply those 100 thousandths. Notice that our part is positioned in the center of the model. But since we faced it in that last operation, let's go ahead and change that to 0, right? Because we already faced the bottom of this part, so it's going to be sitting flush to that soft draw. All right, take a quick look. That looks good. Now the work corner system is in the center of the stock. Let me go ahead and change that then to that corner that we had predefined. click OK. Right, so again, going back to 3D toolpaths now, notice that you have both two different toolpaths and two different, I guess, topics or sections for drop-downs for them. Right, so adaptive clearing, selecting then a 1/4 inch flat. We selected the model to work off of on our setup. So Fusion 360 already knows what it's going to be machining. And again, just click OK. Let's see what the toolpath gives us. Right, it's indicating here that the flute length of the tool isn't going to be big enough. I believe it was 0.5, so let's change that to 1/2 inch.
So this is the analogy you were referring to about the bear, right? It's the remove everything that's not a bear. So in this case,
right,
this F is the bear, the keychain.
Right, that's a good point. This F will be the bear. So Fusion 360 looked at the keychain, and then it's removing the stock that was left over, right? So notice here that we have a decent looking toolpath, except for the fact that it's plunging into our soft jaws, right? So let me go ahead and change the height of how low it can machine and see if that fixes it. Right, so that's a much better looking toolpath. Again, this is going to be a roughing operation, right? So notice those smooth transitions. You're really able to push a tool without having any tool breakage or maybe any cyclic tool loading there as well. Okay, so now what we want to do then, we already roughed it out. Let's go ahead and focus then on the surfacing part. So really, you can use a variety of different 3D toolpaths depending on what surface finish you're looking for, right? So what we decided to go with the demo was a parallel toolpath. Now, pretty straightforward. We liked the texture that parallel was giving us, so we decided to go with that toolpath. But what you're looking for in 3D toolpaths is a toolpath that really accentuates the surface of your part, right? So that's going to be ultimately up to you to see what toolpath really does that for you and gives you the best surface finish, right? So I'm going to go over or through a few of these toolpaths just so you guys can see the difference between them, right? So I selected a morph spiral. I'm going to be using a 1/8 inch blind mill. And again, just go ahead and click OK, see what we get. Right, we get this pretty nice looking toolpath actually. It's really accentuating the surface of it, and it's not really retracting as much. Let me go ahead and contain it then. I want to come in here with a different operation. So let me go ahead and do that. So again, the window that you do the containing for on your toolpath is the geometry window, right? So a lot of people, when they select a chain, it's usually going to be something else. So I just recommend that you select machining boundary selection, and then for the machining boundary, start selecting your chain, right? So notice that this is encompassing the whole part. I want to go ahead and limit the chain to this section here. So let me go ahead and double click on that one more time. Right, and then this is going back to adding the artificial intelligence to that, where Fusion 360 intelligently selects the chain. I want this chain right here. Notice that we get a preview that it's already closed. Click on the little plus sign, and we get the appropriate chain for that. Now, so that we managed to contain the toolpath, right? So again, let's go ahead and look through a few of these toolpaths. 3D milling. Let's see the scallop. Scallop was actually another one of our options. Click OK. Right, so this is going again to how fast you can really compare and really see which toolpath is going to work for you. Now the scallop is looking okay. Let me go ahead and decrease the step over then to 20 thousandths. Click OK.
Yeah, here are all the different finishes that Alex is showing us, because we know it's really important to machinists like some of you guys are machining, that it's really important and professional to leave a good finish. Not only make it with intolerance, but leave a good finish to your part. Right.
So then let me go ahead and then finally just add the parallel toolpath that we had. 20 thousandths, click OK.
So he just duplicated right now the settings of the other toolpath, but it was a completely new toolpath.
Right. Yeah. So this is the toolpath that we decided to go with. Right. So For those of you that did go, you saw the finish that it left.
Yeah,
we were actually pretty happy with that finish. It left some texture, and that's because we left a 20,000 step over. So we would have decreased the step over. We would have had a much nicer finish or less texture right on the part. So here then, the next operation, I'm not going to run through this entire programming. Let me just go ahead and post it, right? Let's assume that we are already ready to post. You can go ahead and post each code or each program individually, or you can just simply select setup. And what's going to happen then is it's going to pick up all the setups that you have defined there, and it's going to create your entire program. Now, notice here too, we also had a question if you can go through this entire setup with minimizing tool changes, then you can, right? So if you have a 1/4 inch flat end mill in the soft jaws and you have maybe a couple 1/4 inch operations here and down here, it's going to do all those 1/4 inch operations first, right? So instead of looking at each setup individually or each program individually, it's going to look at your entire setup or your entire program and see where it has that tool, and again, minimizing that tool change, right? But that's going to be up to you. So I recommend that you be extremely cautious when selecting this option. Right, so posting this program, then notice that we have hundreds of posts here already pre-installed with Fusion 360. So with a lot of other CAM softwares, if you have a couple Haas machines, but then you decide to get a Herco, right, you're gonna have to pay what, maybe a couple thousand to get that post done for you. With this, you really have the ability to just select, which post or which machine you have available to you, right? Notice that you have Herco, you have Haas, Fanuc, all your big time posts. All right, so
right. And if you guys don't see your posts here in this list, we also offer post modifications, custom post modifications here at Katif.
Yeah, absolutely. So notice here too that we have the user properties, right? So we have a few user properties already built into this dialog box. Again, you can modify your posts to maybe add a custom property in here, and then have the ability to select it and deselect it while doing it. Right, so you have G187, right, really enabling high-speed machining inside of your Haas. And let's go ahead and just do yes. Now, again, with G187, you get a p-value associated with that G187, depending on what kind of operation it is. So P1 being a roughing operation, and then P2 being medium, P3 being a finishing operation. All right, so we're pretty happy with that. Let's go ahead and post it. Desktop.
And this is the G code you put on USB and plug into your Haas machines or whatever machines you have.
Right, and here notice that we have then our entire program, right? So very easy. Notice that we pretty much covered the entire workflow of getting your part, creating a set of soft jaws, using the same model that we got from a customer, or maybe that you designed yourself, and then not even leaving the tool, right, in the same tool. And then create a working program, right?
Yeah, and this was one of many tools that Fusion has. So yeah, thank you, Alex, for that demonstration.
Absolutely.
So yeah, we'll address any questions that you guys may had. We have one question here from Steven. He's asking if Fusion 360 has turning, and if it has, or what's the difference between that and Fusion 360 Ultimate?
Yeah, absolutely. So Fusion 360, I guess the first version of it does have turning, right? So you do have turning capabilities with that. Now, the only difference between Fusion 360 and Fusion 360 Ultimate is the 4 and 5 axis machining, as well as some advanced simulation.
We also have a question from Adam. He's asking how do you know if my machine is going to have a post processor here in Fusion?
Yeah, you can either go up here to the post processor tab and check to see if there's a post for you. You can also go online and type in, I believe it was Autodesk HSM post processors, right? And there's an entire list there that with all the posts available to you.
Yeah.
What we can do too, what we've done in the past is find a post that's similar to the code that your current post is giving, and then modify a post here or modify that post inside of Fusion to give you something similar to that.
And also to remind you guys, these Fusion Fridays that we're having is going to not only be on the first Friday of every month anymore, but it's going to be every other week now. So in 2 weeks from today, we'll have another Fusion Friday. We also plan to have another Fusion meetup as soon as possible, and we'll address that. We'll let you guys know for sure when that's happening as well.
Yeah, absolutely. We were very pleased with the turnout at the last CAM event. So we might even do another CAM event. Maybe do something a little bit more complicated using a 4 and 5 axis machine, and just seeing the feedback that we get from you guys.
And we have a funny, just another comment here in the comment section. I saw the angle of the marble and carved it until I set him free. And that was from Michelangelo. So thank you, Jerry, for that. Good last quote there.
So we have a question here from Tim. So my machine, I wanted to do a G57, not a G54. All right, so how would I go about that? All right, so that's a pretty good question. Let me go over here into the setup then. All right, edit the setup. Under the post process, I didn't cover this. I covered the stock and setup, right? But under the post process, this is where you can really determine and define what your work corner system or what value it's going to be associated to. So just for reference, 0 and 1 is always going to be G54. So if we go ahead and put 4, right? So this is going to be for setup 3, I believe. Yeah, setup 3. G50. We put a value of 4 in there. Let's see what we get. Let me just regenerate the first toolpath. Post it again. Haas 1001. Desktop. Right. We get a G57. Right. So again, that's ultimately going to be up to you to really, maybe you have the G54 in use right now, or you're going to be using it for a part prior to that, and you can go ahead and change that work corner. So we'll give it a few more seconds here then to see if there are any more questions. Again, guys, this is just one thing that Fusion 360 can do, right? We're also going to be covering simulation further down the line. I'm going to be covering surface finishes actually in a couple weeks here as well. So tune in for that.
From Josh, he's asked, will the webinar be posted on the web?
Yeah, absolutely. So actually one of the reasons why I'm redoing this was because a lot of people wanted to see a video of that workflow, right? So this is absolutely going to be posted on our YouTube channel after.
Yeah, so if you go to YouTube and look up Kati Fusion Fridays, you'll find a list of the past webinars that we've done, the past 8, including this one will be 9. And yeah, so forth. Let me see if we have any other questions. All right.
Okay, doesn't look like.
Yes. So yeah, if you guys are interested in contacting us for any training, support, and consulting for Fusion 360 or any other Autodesk product, feel free to take down our information here.
Yeah, absolutely.
And we'll gladly talk to you about anything related to that. So.
All right. So thank you guys for tuning in. See you in 2 weeks.